Hi, this is Chris Brown, CIT 381, and today I want to tell you a little bit about a technique called simulation. What do I mean by simulation? Well, simulation simply is the imitation of the operation of a real-world process over time. And it's the process of designing a model of a real or imagined system and then conducting experiments with that model. And the purpose is to understand the behavior of that system or evaluate strategies for the operation of that system. Now today, the simulation techniques we're going to look at calculate the probability distributions. And we'll talk more about what that means. But we're going to look at several types of simulation techniques: stochastic modeling, Monte Carlo simulation, and sensitivity. So let's start with stochastic modeling. Stochastic modeling. Well, it's a type of simulation that traces the evolution of variables that can change stochastically with certain probabilities. Well, what the heck does that mean? I think we need to look and understand, what does that word stochastic mean? Well, the definition is randomly determined, having a random probability distribution or pattern that may be analyzed statistically but may not be predicted precisely. So when you hear that word stochastic, substitute the word random. So a stochastic model then predicts a possible set of outcomes weighted by their likelihoods or probabilities. And the basic process is you create a projection which is based on a set of random values. Outputs are recorded, and then the projection is repeated with a new set of random values, and you repeat that until you have gathered a sufficient amount of data. In the end, the distribution of those outputs then shows the most probable estimates as a frame of expectations regarding what ranges of values those variables are likely to fall in. And again, this might not make sense at this point, but we're going to walk through some examples that hopefully will kind of help make sense out of this. So let's jump into Monte Carlo simulation. What is Monte Carlo simulation? Well, it's a type of stochastic simulation that's pretty widely used, and it's used to model the probability of different outcomes of a process that can't be easily predicted. It was developed during the Manhattan Project and subsequent nuclear weapons development at the Los Alamos National Laboratory. Today, it's widely used in business, finance, and manufacturing. And again, the basic process of Monte Carlo simulation is you create a projection, you record the outputs of that, and then you continue to repeat that projection until you've gathered a sufficient amount of data, and then you look at the distribution of those outputs to understand, basically what kind of ranges of values to expect. So that basic process comes straight from my definition of stochastic simulation, because Monte Carlo is a very widely used example of stochastic simulation. So to kind of wrap my head around this, I read a lot about Monte Carlo simulation, but ultimately I used a tutorial that I found on YouTube, and it helped me create a Monte Carlo simulation of the potential future stock price trend for the company that I work for, Weyerhaeuser. Now, the basic parameters that are needed for that is based on historic stock prices. So that historical stock price data for Weyerhaeuser was my basic data set. The Monte Carlo simulation then calculates probable stock prices for a 6-month future time period. And this particular spreadsheet uses an Excel add-in tool called Yosai that helps to automate that simulation. So what did I have to do? Well, I had to obtain that closing price data. Using that data, I had to find its periodic daily return. I had to find the mean, variance, and standard deviation of that periodic daily return. I had to calculate what's called drift, of those prices, and then set up the random component of those prices for future calculations, and then used the USI tool to automate the iteration of those simulations. And you know, it's actually, if it sounds like it's complicated, it actually kind of is. If you're interested in learning more, I highly recommend watching that YouTube video. I've got a reference to it at the end of this slide deck. But the starting point then was that historical stock price data. And actually, when I pulled it in and started looking at it, I noticed a really drastic change in a very short period of time in 2010. And as I looked at that and investigated, I found that in 2010, Weyerhaeuser changed their company structure to what's called a REIT structure. And the net effect of that was that it drastically impacted the stock price. And so what I found was that if I included this whole set of data in my Monte Carlo simulation, I was seeing some pretty wild forecasts for historical stock prices in the future. And so I determined that I probably should just focus on the historic stock price data after the REIT conversion in 2010. And so that's what I did. So here's the raw stock price data. I started here with 21st of July 2010. That was the event. That was the day after the event of the REIT conversion, and I used the daily stock price data from that date forward. Using the information in the tutorial, essentially what I had to calculate was this average, which again is based on that stock price data, this variance, which is also based on that stock price data, and this standard deviation based on that stock price data, and then this drift, which the drift is calculated based on these other things that I had to calculate. And then the model basically looks at what kind of a return target are you looking to get in the future, and then the starting place for these simulations is today's stock price. Okay, and so I've just included here two representative examples of some of the simulations of that future stock price. And you can see this one, well, it looks pretty good. It's telling me that I can expect after 200 days to have a 37.5% increase in that stock price, which would be totally awesome. I think anybody would sign up for that. On the flip side, it shows that, you know, one of the simulations predicted that I could have a 32% drop in that same 200-day time period. And so you can see that the simulation is kind of framing, well, you know, here's some of the possible outcomes. Here's kind of the range of possible outcomes. Really, to completely analyze the data, you have to use the USI. Basically, it's pretty simple. You just tell it how many iterations you want to go through. I said 5,000, and it didn't take too long to go through that. And then it calculates all. It basically runs through that simulation 500 times or 5,000 times, and keeps track of all that data. And then it basically documents here the statistical information from all 5,000 of those simulation runs. And so then you can use that data, you can review it, and it will kind of tell you then what the most likely probable scenarios are out of those 5,000 simulation runs. And that'll give you then a better idea of kind of what the most likely scenarios are in terms of that future stock price. So that's the Monte Carlo simulation. Let's move on to sensitivity analysis, which is not really a stochastic method, or doesn't have to be a stochastic method. And in fact, the demonstration that I'm going to show you just has some solid calculations. But what is sensitivity analysis? Well, it's a technique used to determine how independent variables impact dependent variables under a given set of assumptions. And so maybe the simpler way to think of it is it's also called what if analysis. And I think as I show you kind of the very simple model that I built, that'll make a little bit more sense. In a nutshell, it's a way to predict the outcome of a decision given a certain range of variables. So for my example, I wanted to take a simple financial calculation and perform a sensitivity analysis using that calculation. And so the calculation I've got here is called terminal value, and I'm really not here to kind of help you understand what that really means. You'll have to do your own investigation to kind of figure that out. But essentially what it does is it takes a number called the free cash flow. It takes a weighted average cost of capital percentage and a growth percentage, and based off of those calculates this thing called terminal value. Really what the sensitivity analysis is intended to do then is to show, okay, well, what happens if I change this weighted average cost of capital? What if my cost of capital changes? What kind of impact does that have to my terminal value? Or what if my growth estimate changes? What does that do to my terminal value calculation? And so you can see in this table here then, going across the top is changes to the weighted average cost of capital. Going down the column here is changes to the growth percentage. And these numbers here then show the impact to that terminal value calculation. Well, how did I do that? I used the what if analysis feature of Excel to run those calculations. And essentially what I did is I put these percentages going across the top and these percentages going down the side, and then this terminal value from this calculation goes right here, and then you basically just highlight this whole block of cells. You go to the what if analysis and you go to the data table piece of that, and then you just basically plug in for the first piece of information that it references this cell, and the second piece of information references the growth, and then it knows what to do with it from there, and it runs the calculations and shows you then the impact of what if my cost of capital changes, what if my growth changes. And that's really what a sensitivity analysis is supposed to show is, what if this variable changes here, how does that impact the dependent variable? And it really doesn't get any more complicated than that. So hopefully that's helped you understand what sensitivity analysis is. That's it. Thanks for watching. I really appreciate your time. And if you're interested, I'm going to take just a few more seconds at the end here, and I'm going to show you the different references that I found for all of this material, just in case you're interested.